Hi, I am Mithun Chakravarti, and as a part of my project, Efficient Layout Implementation of a Cmos Inverter using Cadence tools, in this first video, I will show you the DC analysis and transit characteristics of a Cmos inverter. Then, in the second video, I will implement the layout of Cmos inverter and check the created layout is matching with the schematic or not. Let's continue. Thank you.
And now for performance schematic layout of this Cmos inverter, I am going to use VMware Workstation in which I am installed Cadence software. This is my VMware Workstation and I resume my Cadence software here. Yeah, now I'm going to terminal, and to invoke Cadence, I need to use the command virtuoso.end. And now it's loading. And now we can see that it was successfully shipped out. And now we are going to create a new library, and our library name is analog DA. And now I am going to attach it to existing technology library, that is GPDK90 file. And now you can see that analog DA is successfully attached to GPDK90 file. And now we are going to create new cell view. And since we are going to do CMOS inverter, my cell view name would be CMOS inverter. And press OK. Yeah, we can see that our schematic editor L editing is being created now. And we are going to perform our schematic capture here. And for creating instance, I used a I shortcut here and select GPDK90 file and select Cmos 1 voltage. And the shell by this. And select the symbol and press enter. And now place that Cmos in the layout. And now do the same for NMOS also. And now our PMOS and NMOS have been successfully placed in the layout. And now use W option for connecting wires of PMOS and NMOS, as I'm showing here. And now we successfully created we connected our wires now. And now we are going to add our pins. So that just press P shortcut and enter V in for our input voltage, and set direction to output, and our name of that pin is V out, and place it there as shown. And now we are going to create bidirectional input and output, which is VDD and ground. We can just mention space between that so that we can do the same at a time. VDD and ground. And now connect V into the wire as shown, and to V out as well, and ground and VDD also. Just press M4 to get out of that selection window. And now we select check and save to check is there any error or not. Now we can see that there is no error since there is no window popping out. And now we successfully created our CMOS inverter. And now for creating symbolic view, since we cannot use this circuit every time, we are going to go to cell view, and to create symbol it should be a symbol view, and press OK there. And our left pin is VN, right pin is V out, and top pin is VDD, and bottom pin is our ground here. And press OK. And now we can see that our editing invert symbolic view is open, window is open. And now just use delete key to remove that outer selection boxes. And now just press M key for getting into selection window. And now use capital R key to rotate and place the terms as shown. And now use the narrow wire option to create a wire like that, and create a triangle like structure there. And you can use that circle option to do circle, to place that not symbol in front of that triangle symbol there, as shown. Do it as shown there. It takes some time to do that. Since we cannot use that schematic capture every time, we are going to make our work easier, we are going to use this symbol for performing a transient and DC analysis. And now change that instance name by pressing Q option to get editor window, and change it to inverter there, and press OK, and place that inverter name inside that triangle over there.
Well, he was resting and did more time, but it was, yeah, I'm really excited getting plug it on. And that.
And now we are going to create a selection box outside, so that select automatic there, so that it get selection box will select automatically. And now perform check and save to check whether there is an error or not. And now we successfully created our symbolic view of our Cmos inverter as shown. Now just close that window. Yeah. Now we are going to perform our DC and transient analysis, so that create new file as the name Cmos inverter simulation, and press OK there. And we will be redirected into new schematic layout, so that now we are going to add instance. Now for this time we are going to select from analog DA and select that symbolic view as shown, and place it in the screen there. And now if you want to see what's there inside that, you just select that and enter Shift E, so that you can see that our schematic layout will be displayed there. And now we are going to add instances from analog DA, like analog library. We'll just select in the cell option, select VDC for DC voltage and press enter and place it as shown. And now for input, I'm going to use pulse, so that and search for V pulse there. And select that and enter. And now browse for ground and place the 3 grounds over V pulse and under our symbolic view as well as our VDC respectively. And place VDD above our symbolic view as well as our DC voltage. A press symbol over there. Yeah. And now press W for connecting wires as shown. Connect it to ground and ground to ground and VDD to VDD. And our DC ground to ground and input to VDD as shown. And now we are going to place input and output pins, so that press P for getting into that window and place V in refer to our symbolic view and V out as well. And now use W to connect wires. Now we'll get a node over there and V out to V out as shown. And now we are going to edit the properties. For editing the properties, just select that pulse over there and press Q option. Sorry, I deleted this. I am doing it again. Search for V pulse. Yeah. And press Q option for entering into editor window. And now my voltage 1 should be 1 volt. You can even use 1.2 volt over there. And my period should will be 20 nanoseconds. Go again, press Q, 20 nanoseconds, and my rise time will be 50 picoseconds, and my fall time would also be 50 picoseconds. and pulse width is 10 nanoseconds. Yeah, and just press OK there. And now you can see that the parameters are successfully loaded to vPulse, and do same for DC as well, VDC voltage as well. DC voltage would be 1 volt. Press OK. Yeah, and now perform check and save option to check whether there is any error or not. And now since there is no any window popping out, we can confirm that our circuit for analysis is done perfectly. And now we are going to simulate this. To do that, go to launch and go to analog design environment. And now we are going to add our vPulse and VDC to the analysis section. So that go to edit option over there, and yeah, I'm going to perform transient analysis and DC analysis. So that select transient analysis, and my stop time is 100 nanoseconds. Select moderate and press apply, and we can see that our transient analysis has been added to our analysis section. And do the same for DC and save DC operating point and select component parameter. And to select my component, just press that select component. You would be redirected to our schematic layout capture. Now select VDC component parameter and press OK there. And now I need to perform analysis for input voltage, output voltage and VDD, or just input voltage and output voltage to check our analysis. So my start and stop would be 0 and 1, and press apply there. And to select my outputs, go select it from schematic there as shown. And now select the cursor on the wire of V in and V out, and we can see that in the left side it has been selected, and V in and V out, and VDD as well. Select that node for that VDD. Yeah, and press OK there in the analog design environment. And now go for this analysis section, and we can see that both trans and DCs has been loaded, and run the option, select the green symbol over there to run. And now we can see that our simulation results has been shown. And for separating V in and V out, just press right click in the transient response graph and use trace option there. And now we can see that for the low input voltage, the output is high. For high input, the output is low as shown. And now the right side graph corresponds to a DC response of our Cmos inverter. It is V in and it is V out. Yeah, hence we successfully performed our simulations.